Dear students, this is chapter number 3. Chapter number 3 is based on how big data adoptions can be made and what are the planning consideration for the big data. So, in this chapter, if you look at the first figure 3.1, and in this one, what special thing we have it that we are having three different kinds of data. The first is relational data, which is the structured data. Second is like textual data. It could be like XML file, it could be JSON file, or it could be normal unstructured data, both. So we have semi-structured or unstructured data, and image files. They're also considered to be a unstructured data. So from unstructured data, what we do, what the big data analytics, they extract the information, and a person profile can be made from it. Like for example, there's a person from his age is 27, he's married, he has two children, he lives in New York, and he usually orders pizza. So this information can be derived from the social media, and he reads non-fiction novels, right? So his interest is also taken from the social media. His records, he's like, is about information by data from the structured data and unstructured data, and this has been derived over there. So it means that from the big data we can do personal profiling, or the profiling of the people or employees or customers, or any kind of like profiling we can do it. And this profiling is very important in marketing. There is a one disadvantage which is attached with it. It is related to the cybersecurity when we are using NoSQL, not only SQL database, and it can be like susceptible to the attacks by the attackers or intruders, because there is not enough security measure is made on the side of the big data. For the structured data, we have high security provided by the Oracle, but with the unstructured data, where we use Hadoop and we use Cloudera, in that case, the security might not be that much stronger as it is considered or deemed to be stronger in the structured data. So here in this figure 3.3, we data can be annotated with the source data attributes, or it can be like with the data transformation steps. So here is what you see here. Here we have like data along with the metadata. So what is the metadata? Metadata is the data related to the data, or data of the data, or the source of the data, or the structure of the data, we call as a metadata. For example, if the employee name is there, so employee name could be like a character data or categorical data. If say employee number, so we call it could be integer, right? If you say salary of an employee, so that could be a real number. So this kind of information is stored in a file, and that file is called a metadata. So metadata receives the information related to any data and keeps with itself, right? So for any textual data, we extract the metadata, we process it further to the step 2, and we store into the DBMS for the enterprise boundary. So in the first step in the metadata, we extract like source ID, acquired data, and size. In the second step, we have some further more processing steps we did it, and in the second one, we had another processing step. So there could be a series of different steps involved in a big data in a big data formation. This slide is about the storages, that how much storages we needed, because in big data, as we know, that there are like three more important things, like a high volume, high velocity, and high veracity. And further to like veracity and value is also included in that one. So that's when we need petabytes of data. And if you just like do it in a normal way, so it takes like 2750 hours for processing this kind of data. So here, like each repetition can help fine-tuning of the processing steps like algorithms and data models to improve the accuracy of the results and deliver greater value to the businesses, right? So this step, if you look at this diagram, what are the important things we can see over here? The first step, that IT personnel, they acquire the data, they extract the data, right? And then they process the data. And after processing, definitely they will analyze it for certain business problems or business use, and then they visualize it for higher personnel managers so that they can have some strategic plan on that one and can decide their future plans. So the last topic of this chapter is about the life cycle, the big data analytical life cycle. That what is that one? And there are 9 steps over there. So the first step is about uh, business case evaluation. Second is data identification. Third is about data acquisition and filtering. The fourth is the data extraction, and the fifth one is data validation and cleansing. The sixth one is about data aggregation and representation. Seven is the data analysis. Eight is the data visualization, and ninth is utilization and analysis result. So we will discuss one by one that what does it mean, the first step to the ninth step. So the first step is the stage number one, that for any big data analytics life cycle, we must start with the first step. So the stage one is business case evaluation. We need to see whether what kind of case we have, whether it's like the data is related to medical or engineering or businesses or what are the different cases. So we need some field expert for that one to help the technician of the big data analytics so that the analysis becomes more accurate and the data can be easily stored into the data warehouses and it could be easily analyzed. The second step is about data identification, that how the data identifications work. So you need to identify the data, and sometime in data warehouses what we do denormalization. So in the denormalization, we combine the different tables over there and we squeeze up the data so that instead of 5 tables we convert into one table, or instead of 100 tables we convert into 2 or 3 tables, so that the processing become faster, because in the data warehouse the size of the data is larger. So in that case, while shifting, when the computers keep searching from one table to another table, the processing time increases. So data identification is very much important to know that what are our attributes, what are our dimensions, so that we can easily know that how many dimensions or attributes or columns we have it. Stage three of this one is data acquisition and filtering. Yeah. So this is very important, that we need to filter up the data and remove the unwanted thing. So data acquisition is also a very hard job, because you need to contact different departments. Let's suppose in one organization you might be having like departments like marketing, sales, procurement, and an IT department. So all these needs communication, strong communication and coordination. Okay, this is like following up a diagram with it, that how we acquire the data. So in that one we need to make the metadata is added from the internal and external sources. So when you receive the data, you must know that what kind of data it is. You need to explain the data with respect to integer, real numbers, and with respect to character values. As in SQL structure, we have it numbers, which is related to like for the integer we have real numbers, we have a varchar 2. Now to the stage number 4, what we have it in the life cycle over here, data extraction. So data extraction is also important, and it is follow up with the data acquisition and filtering. So sometimes we need to extract the data from the existing data. Sometimes we combine two data. For example, if you have monthly salary, so how can we have a annual salary? So we can extract the different data as per the requirements. So here, for example, from JSON file or for XML file, how we can extract the data from for the user ID. So we can easily extract it to our required dimension or required column. And these are the certain example from XML, and this is from the JSON. So the JSON and XML are similar, but JSON is like widely used. Data validation and cleansing, this is also important because sometimes we have unwanted attributes which needs to be deleted somewhat. Sometimes we have missing values which needs to be also updated. Okay, so now we have like in this one, yeah, so data validation can be used to examine the interconnected data sets in order to fill the missing valid values. Sometimes you have two data sets, so you need to cross-check whether the values are same or different, right? So if it is different, then you need to validate it and check why they are different. If there is any logic behind it, you can keep it. If there is no logic, you need to validate and correct your data. Yeah, this one is showing some spikes or some peak points. Okay. The presence of invalid data is resulting in the spike. So it means that this is like, visual representation of invalid data. So you can spot the invalid data and you can like, remove it. Although the data appears abnormally, it may be indicative of the new patterns. Stage number 6, what we have in the stage number 6 is like data aggregation and representation. Sometime, as I told you earlier, that we need to combine some of the data for business purposes, and we need to represent in a proper manner or in a proper tabular form or in a graphical form. So for example, if this data we need to aggregate it, so aggregating mean addition. So when you want to add two data, so here in this one, the ID is repeated. So the ID will be removed over this. So now instead of 4 columns, we have 3 columns. So we save the space as well. So the simple example of data aggregation where two data sets are aggregated together using the ID field. So here we use ID field as like a primary key we use in Oracle SQL. And now we have here data sets A and B can be combined to create a standard data structure with the big data solutions over here. So this like data set we have A and data set B, and these are combined in this section. So it's also kind of that how we can make the data as a standardized form. Data analysis, yeah, so we have different techniques for data analysis. We can use some normal exploratory data analysis. We can use machine learning. We can use deep learning analysis. So it depends on the level of demand from your top management. So yeah, these are certain symbols which used for normal data analysis. So here is kind of exploratory data analysis where you find just like top value, highest value, lowest value, mean, average, standard deviations, right, or variance. But here in data mining, we have supervised learning, unsupervised learning, and reinforcement learning. And the data analysis, it also have exploratory and confirmatory analysis. And the second last is about data visualization. So data visualization, we have different techniques, different charts and graphs over there. We can have like from a simple bar chart to the complex like whisker box chart, or we can go for some geographic charts. We can go for different kinds of charts available in the Excel sheets, and also you can use Tableau for visualization. Okay, so the last step is like utilization of analysis results. So in the last step, what we do is that after we visualize it, we need to hand over these results to our top key management, and to so that they can make a strategic plan over it, and for 1 year or 2 years or 5 years, and then they can like take benefit from the existing data from the last 5 years or 10 years in the data warehousing. So then after all these 9 steps, then you can utilize it. Otherwise it will be difficult to utilize the direct data from the OLT operational data or from the OLAP. Thank you very much.